This is an introduction to indoor air quality and the importance of it in the corporate setting. My name is Scott Dupre. I'm a graduate research assistant at South Dakota State University. Two other people that have put time into this presentation are Taylor Sees and Dr. Stephen Gent. HVAC systems are at the heart of influencing the quality of indoor air in a particular facility. Studies have shown that indoor air quality is a significant factor when it comes to the quantity of sick days taken by employees, accidents experienced on the worksite, and overall workplace productivity, particularly contributing to sick building syndrome or SBS. By investing in a well-designed HVAC system, building operators can help improve the general workplace environment, increase employee satisfaction, improve the overall health of the employees, and increase workforce productivity as a result of having a more secure, safe, and comfortable environment to work in. Heating, ventilation, and air conditioning, or HVAC systems, are responsible for defining the characteristics of the indoor air in a space, particularly the temperature control, amount of fresh outside air, recirculation of indoor air, and humidity. These characteristics directly impact the quality of indoor air and contribute to the health and effectiveness of the people occupying those spaces. Temperature control of the space tends to be around 70 to 75 degrees Fahrenheit year-round in standard commercial environments, but can vary based on the particular function of the space. To maintain this temperature range, a large portion of the energy consumption of a building goes towards conditioning the outside air supply to the desired temperature range. Thus, the incoming fresh air supply and indoor air recirculation are important to assess indoor air quality. Because of the high energy demands required to condition the outside air supply brought to a building, this airflow is typically kept at a code-required minimum during HVAC system design. Thus, a large portion of the airflow in a space is simply indoor air recirculation, where return air from the various indoor spaces is recirculated back to the HVAC system to be reconditioned and distributed to other locations in the building. Increasing the quality of air in a space is best achieved by increasing the amount of fresh outside air that is brought to the space, as this decreases the amount of return air recirculation throughout the building to decrease potential distribution of contaminants such as viral aerosols from one space to another space. Another alternative presented by the American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE for short, has been to implement what they call a fresh air purge for a short period before and after building occupancy every day. In this method, increased outside air amounts are brought into the building during these purge periods until the air in the building has been completely replaced with new, fresh outside air, removing any residual contaminants or particles present in the indoor air. Obviously, the main drawbacks to these methods are that the amount of energy required to condition this outside air is costly, thus an intricate balance needs to be maintained between how much fresh outside air should be introduced and conditioned compared to how long the conditioned air should be recirculated through the system before being exhausted. Another option to improve indoor air quality that is less commonly used in HVAC system design is to consider the airflow patterns within a space by making sure that the supply air adequately conditions the space while also being efficient in its return path through the room can allow the HVAC system to continue to provide lower amounts of fresh outside air while also reducing the potential for contaminant distribution throughout the space or other adjacent spaces. For example, the functionality and personal layout within a room play a significant role in the potential transmission of viral aerosols from one individual to another via air transfers. Other options of air treatment to increase indoor air quality are also possible. Increasing the filter rating at an HVAC unit can help remove more contaminants and particulates from the airstream, but the existing HVAC system may not be capable of providing the supply air necessary with the extra resistance from a finer filter rack. Additionally, other systems such as ultraviolet or UV and ionization can help to kill and remove potentially harmful particles from the air stream before they can reach the occupants of a space. But these can require significant upfront capital costs and updates to a current HVAC system design, which can be costly. With regards to humidity, general recommendations are that HVAC systems be designed and tuned to keep the space relative humidity at a 30 to 50% range in commercial buildings year-round to help maintain a healthy immune system by the occupants, while also maintaining comfort. Relative humidity below 30% can result in a weakened immune system due to the dry air evaporating out of the mucous membrane of the inhabitants, which are the first line of defense against potential viral transmissions and infections. This can contribute to a higher quantity of sick days per employee. Alternatively, relative humidity above 50% can result in mold formation over time within the space and other air quality issues. Additionally, high relative humidity can begin to cause occupant discomfort, which is among the top 3 causes of workplace accidents, along with drowsiness and overexertion. Dehumidification of a space in the more humid summer months tends to be rather common, with the ability to provide portable space dehumidifiers, as well as increasing use of hot gas reheat HVAC systems to overcool and reheat the incoming airstream to condense moisture out of the air. However, humidification of a space in the winter months tends to be a bit more tricky and less common, as potential for condensation at the cold windows and exterior walls of a space can be a significant issue. Thus, humidity levels can reach well below 30% in the winter months. Interestingly enough, these winter months also typically correspond with the higher viral transmission rates of infectious diseases among building occupants, which are then aided by this lack of humidity control and reduced amount of incoming fresh outside air to reduce energy loads. With more of an investigation and investment into an HVAC system's performance during the winter, the spread of disease can be mitigated to reduce the intensity of the flu season or extent of other viral spread events. Sick building syndrome is a phenomenon commonly used to describe the long-term effects that extended periods of time in a particular indoor environment can have on the occupants residing in that building. In rare cases, these effects can happen in a matter of hours, particularly if the air is untreated or a chemical odor is being presented into the space. Indoor air quality has a direct impact on how quickly SPS can affect occupants. For example, SPS tends to occur more commonly in the winter months, when indoor air quality measures tend to be reduced and amount of time that employees spend in indoor environments is typically increased. Short-term symptoms of SPS can include headaches, coughing, and lightheadedness. Occupants tend to show signs of these symptoms toward the end of the workday, but they can vary per case and can be more prevalent if a chemical odor is present or introduced to the space throughout the day. However, long-term symptoms of SPS can include extended drowsiness, weakened immune system, and acute discomfort, all of which are common signs of indoor air that is not conditioned or distributed properly. The CDC estimates that the flu has resulted in between 9.3 million and 45 million illnesses each year in the United States since 2010, with most infection rates happening between the months of December and February, or what is more commonly known as the flu season. As mentioned previously, this is because the human immune system relies on a mucous membrane as the first line of defense against viral infections, and the efficiency of those membranes is dependent on the amount of moisture that is present in the surroundings. For example, dry skin tends to promote dried out membranes as well. Once these membranes dry out for an individual, they are more prone to viral infections and disease, as this mucus layer is not as effective at catching and stopping these contaminants from entering the body. Indoor air quality can have a significant effect on this, as dry air due to improper humidification of a space can provide an environment not suitable for proper function of the human mucus system. Thus, proper humidity control, particularly during winter months, can help keep occupants healthy and safe. According to the Bureau of Labor Statistics, or BLS, there are at least 2.8 million non-fatal cases of workplace accidents that take place every year in the United States. The 3 leading causes of accidents occurring are drowsiness, discomfort, and overexertion. These problems can often be directly related to SPS. By taking the precautions of implementing a well-designed HVAC system, individuals can help stop workplace accidents by simply improving the quality of air in the building. However, there are other ways to increase the quality of air without adjusting your HVAC system. Examples of this are to make sure spaces aren't overcrowded, ensuring all machines are properly disposing any odors through an air filter or directly to the outdoors, and opening windows if possible. Workplace productivity is defined by an employee's happiness, comfort, motivation, and mental or physical ability to perform a task. Aspects such as happiness, comfort, and motivation can be influenced by creating a safe and clean environment with good quality indoor air. According to the Centers for Disease Control and Prevention, or the CDC, productivity losses linked to absenteeism cost employers $225.8 billion annually in the United States. That's $1,685 per employee. Promoting safe and healthy work practices boosts profitability and productivity among employers of all sizes. So as an employer, what can you do to cut down on costs? The answer is by investing in a more well-designed HVAC system, you can increase the quality of indoor air to fight the effects that sick building syndrome has on occupants, leading to a healthier and safer work environment, improving employee morale, and improving your company's bottom line, all in this process.